Hey everybody, welcome to the Tone Church. Today we have a very special episode here. We are going to service and restore a vintage wooden box. It's riveting stuff here. As you can see, it's made out of wood. It's got a little, it's got loose parts on the inside. Might have a present inside. Got a nice little latch, a nice handle. And on the bottom it's got feet, which I added. Got some feet from Bezos and just popped those suckers on. And it's also got feet on the back. But yeah, whatever, feet, hinges. Alright, so got a nice little wooden box to work on today. Let's see what that present is inside here. Oh! Whoa! Well, this will come in handy. We have ourselves a Superior Instruments Company tube tester, model TV-11, made in USA. Made in the 50s, forget exactly when. Manual doesn't tell us, but it was the 50s. It's the good stuff. I like that. It's got some real Art Deco looking stuff. Bunch of sockets. Some dials here. Bought this used, obviously, off of eBay for what I think is a very good deal. If it works, it'll be a good deal. We have our top cap wire, anode grid cap wire thingy, and some switches, and yeah, all the usual tube checker stuff. Alright, so what we need to do here with this sucker right off the bat is replace the power cord. I'm not going to trust that guy. We'll slap some knobs on there. I'm sure I have some knobs here that'll work. And then we'll pop this sucker out of our vintage box here and take a look on the inside. Alright, if all that sounds interesting to you, I'm not sure why it would, but if it does, sit back, relax, grab yourself a nice mug of swamp water.
The Swamp Thing.
There goes the neighborhood.
And come along for the ride. Here we go. Alright, so I'm trying to put knobs on here, and here's a little peculiarity. You can see that the potentiometer shafts have a flat end, and that's normally where the set screw in the back of the knob would tighten up to. But, so for this one, that would be like that, which means it's going to turn from there to there, which is odd. But then this one, these are both turned all the way clockwise. So that would be this guy, and it can't go any more clockwise. That's all the way. So, I don't know. It'll still work. We'll just set the set screw on a round portion of the shaft, but it's a little weird, no?
These are thoughts. These are things that make you say.
And then this guy right here, he's got a brass shaft with no flat end.
That's what she said.
Interesting. Oh, what's this? Somebody got some spooge on here. Alright, anyway. Minor troubles. We'll get it done.
We do have in my parents' home a petrified rhinoceros penis.
If we look at the photograph on the tube tester manual here, it looks like these two knobs were chicken heads, and this is just like whatever that's called, regular round knob. And again, with the flat parts on the shafts, I don't know what's going on. But anyway, this is what we're using. Skirted chicken head knobs here for these two, and we have a round knob. And this is where this guy ends up. Oh man, the lighting on this. Who's in charge of this video? That's what we're getting, but whatever. That's not important. These are more important because we kind of need to know, you know, the proper filament voltages and, you know, the load. But I'm sure it'll be fine. It's going to be the least of our troubles. Alright, let's pop this sucker out of our vintage box here and see what the heck's rattling around in there. I forgot about this part here. It's kind of important. The roll chart seems to have come loose from the roll. So hopefully it's still in there, and that'll be an easy fix. We're about to find out. Alright, we got the chassis out of the box. if you're playing the home game, you only need to do the screws that are on the very perimeter. These two screws, I believe, it looks like they're just for a little case for the roll chart. So you can leave those in, but just the ones around the edge. And this is what was rocking around down there. It's a locator pin for a vacuum tube. Bummer. Alright, let's keep going. Alright, I've got the action cam set up on Mr. Tripod. Hopefully you can see everything here. This is going to be difficult to film. Pop this sucker off here. There we go. You see all that? Get some light on the scene? Probably not. Yeah, how's that look? Looks like an old piece of gear. Got a bunch of dust in there. A little lamp right there. Oof. Oh, look at this. This guy came disconnected. So it definitely would not have been working. Wow. Got the barbell resistors. Yeah, we're gonna have to replace some components here. Look at these bad boys, huh? Wow, that's cool. What are we gonna do? We'll get this guy out of our way. Start. It's the power cord. Be gone. Your services are no longer needed. But we might use you as speaker wire at some point. Yeah, let me take you off action cam so we can get some close-up shots of all the dirt. Alright. We have a pretty stout looking transformer here with all sorts of leads on it. I believe every filament voltage on the dial has its own tap. Could be wrong about that, but it's the first thing that pops to my mind. We get all nice vintage cloth covered wire.
This is beautiful. What is that, velvet?
Looks like we got bonding bus. We have our meter. We have a whole lot of dirt there. Yikes. There's not a whole lot to it. There's a couple of components. I think there's a total of 2 capacitors, which would be him and him. A few resistors, and it's basically just wires and switches, and dials and sockets. The complexity is only in the amount of crap, not the actually what it's doing. Here's our roll chart holder. There's the thing I said those other 2 screws are holding. What are we gonna do? What is that? Is that some kind of insect? I don't know what that is. The box has got some kind of zit. Alright, so we're going to clean off about 70 years worth of DNA out of this thing. I'm going to put on a hazmat suit and grab a toothbrush and go to work. Get all the dust and debris out of here. And then see how it looks, and we'll pick it up from there. But so far so good. I think she might work. I mean, as long as the transformer works, we can definitely work with that. The filament voltage knob, when you turn it, it feels crunchy. So we're definitely going to be cleaning, you know, all the contacts of all the sockets and levers and dials. But one thing at a time. First things first. Let's get the dead skin cells out of here. So we got her cleaned up a little bit. Got about 30 years worth of the DNA off of here. And I took a whole bunch of still photographs, which I'll probably make a slideshow for you as a reference.
Tall and tan, young and lovely, the girl from Ipanema was walking, and when she passes, each one she passes goes on. sway so cool, sway so gentle that when she passes each one she passes goes on. Oh, but he watches so sadly. How can he tell her he loves her? Yes, he would give his heart gladly.
And when you clean this up, you definitely want to use a soft bristle brush, because if you knock off a wire or a component, good luck figuring out where it's supposed to go. But hopefully we don't have that problem. I believe this rheostat here is the calibration item. There is one video out there. I'll link to the video on how to do it, but I believe you set your line adjust to your proper wall voltage, and then you adjust this to like 25 volts off one of the contacts, something like that. But we'll worry about that when it's time to worry about that. Alright, so first things first, let's see if we can't fix the roll chart. Alright, the little box here that holds the roll chart here has 4 screws, and these are different than the screws that hold the chassis to the box. The chassis holding to the box screws are pointy. Can you see that? Probably not. And these are a little bit bigger and blunter with a coarser thread for the screws that hold that on. Alright, let's see what we got under here. Oh, it's one little separate unit. Oh, there we go. There's our roll chart. You guys see all that? Nah, you can't see shit.
Damn. I can't see fucking shit out of this thing.
Yeah, hopefully this will be an easy fix. Hopefully we just need to tape this back onto the lower dowel here, and we'll be good to go. But she seems to be very smooth, and yeah, shouldn't be a problem here. Just a matter of tape giving up the ghost. 70-year-old tape. Can't live forever, even if you wanna. Alright, so the paper wanted to wrap around the top tube and didn't want to play nicely, so I just stuck a little screwdriver under there and rolled the top tube and kind of fed the paper up over the screwdriver, and then I was able to get it out like this. And we'll just grab some tape and tape her on there. Easy fix. I like it. I don't have any clear tape in the church right now, so I used painter's tape, and it might be a little too thick and a little too inflexible. It kind of deforms the roll in a way that isn't conducive to, you know, rolling a giant, 84-foot roll of paper here. So I'll get some tape and I'll address that in the future. One thing I did notice when I was researching this and buying this is you can get the addendum to the roll chart online in a PDF format, but I was trying to find just the regular original roll chart online in PDF format in case, because the listing, showed this. You couldn't see if there was a roll chart or not in here, so I was looking to see if this information would be available online in PDF format, and I did not find it. So what I'll do is I'll set up Mr. Tripod here, and I'll go through the whole roll, and, if you need this information, you can just pause it. Here we go.
Goes on. When she walks, she's like a samba that sways so cool, sways so gentle that when she passes each one she passes goes on. Oh, but he watches so sadly. How can he tell her he loves her? Yes, he would give his heart gladly. But each day that she walks to the sea, she walks straight ahead like a tea. Tall and tan, young and lovely, the girl from Ipanema was walking in. When she passes by, but she doesn't see. watches so sadly. How can it say he loves her? Yes, he will give his heart gladly. But each day that she walks to the sea, she walks straight ahead, not a peep. Tall and tan and young and lovely, the girl from Ipanema's walking in. When she bears a smile, but she doesn't see. She doesn't see. She never sees. She doesn't see. She never sees.
All right, we gave the windshield a nice wipe down, and we got her back in place. And it was kind of weird. There's 4 rubber feet or grommets. So you got the chassis, then you got the windshield, and then you got the box. And 3 of the rubber grommets were on one side of the windshield, and 1 of the rubber grommets was on the other side from the factory. So I don't know what happened there. But yeah, got her in place. I think the next step is let's scrutinize the schematic in preparation of replacing some of these old components. While I'm working on this, I'm watching the latest episode from X-Ray Tony B. He's really taking us to church today. If you haven't seen his channel, check him out. He does a lot of hi-fi stuff. Very knowledgeable. Very cool. I think hi-fi is the way to go. I need to stop messing around with these silly guitar amplifiers. I mean, the hi-fi customers, they'll spend $5,000 on fucking speaker wire. There is definitely a gold mine there. Alright, there she is. All nice and in focus. Oh, no. Where's the one we want? Oh, keep going by it. Come on. Bam. Here we go. So our grid cap, anode cap, top cap, whatever you want to call it here, it's in rough shape, kind of all broken. I'm going to replace it with one I had in the junk bin. I think that'll be a little bit nicer. If you're playing the home game, you get an old piece of equipment and you're doing what I'm doing here, exposing a new section of conductor and soldering onto a component or an item, you're going to want to clean the conductor with some alcohol and tin it before you hope to expect to solder it to anything. I think we're missing pieces on the inside of this thing. These are not the droids we're looking for. That's alright, I've got a new one from Amplified Parts. It's a ceramic one. That's okay. We'll use a ceramic one. Alright, I cannot seem to locate the other grid cap I have, but I do actually have more coming in an order that is on the way. So we'll come back to that. We'll move on to scrutinizing the schematic and seeing which components need to be replaced on the backside. Look at that. That looks awesome. How cool is that tube, right? That's what I'm talking about. Here is our schematic, which is in the user manual. Very convenient to have. The user manual is readily available online, but I'll try to remember to put a link to it. And how cool is this thing right here? RCA, baby. And I thought this was a light bulb, like an indicator lamp or a short indicator lamp for testing shorts and tubes, but actually I think that is the this guy right here. I think that's a diode, right? That is some old-timey shit right there. Hopefully it's still good, because, yeah, come on. Come on. Alright, so I'm just trying to match all the components on the back of the board here to the schematic. which is not in focus, so that's definitely making it challenging. Alright, something seems funny here. If you look at each of the levers, it looks like they have 9 contacts on there. But if you look at ours, they, if I can do this, they only have 4. Alright, so there's that. I may be mistaken. I'm going to investigate this some more. But I have a feeling this is not the correct...
This may seem terrible, but oh my God, I didn't know you were black.
I'm retarded. These are the tube sockets. Duh. Here are the sliders. Glad we got to the bottom of that. Alright, this is sure to confuse my simple mind here. But if we look at the levers, from top to bottom, it's F and PK. So, flip this sucker over. And when we put the switch all the way to the top in the F mode, it's actually this bottom connector. But on the schematic, it's the top connector. Good times. So they're reversed, that's what I'm saying. No, I'm saying. And the confusion continues. So our top cap, which is this red wire here, is supposed to be connected to the F bus. Alright, which would be the bottom rail here. But if we look, he's actually connected to the N bus. I don't know if you can see that. But the second lug on the switch from the bottom. Ay, ay, ay. I don't think this has been molested by anyone. I think I'm the first person to be in here since it left the factory floor. So I'm not going to try and reinvent the wheel, because again, we have a earlier version than this revision of the schematic, but yeah, good times. Alright, I think we're about ready to start molesting this thing. So we have an electrolytic capacitor, and we have 2 resistors in series. I'm not sure why they did that. You know, maybe they didn't have the value they needed on hand, or, you know, maybe by putting 2 in series like this, they were able to get a tighter tolerance, but who knows. So, that would be these guys right here, 47K, and the 0.5 micro at 200 volt capacitor. Measured these in circuit, and this guy was measuring around 60, and this was measuring around 2 micro. So we'll pop them out, and we'll pop these guys in there. We have a 47 at 250 and yeah, 47 micro. Oh no, we don't want 47 micro. Hold on, I got the wrong shit here. Alright, so the next thing that makes me go, here is, they're using the schematic symbol for an electrolytic polarized capacitor. We'll get the frowny side on the negative. But that's a 0.5 micro. And then this other guy here, same deal. The symbol for polarized, but that's a 0.01 micro. That is an extremely low value for an electrolytic polarized capacitor. So I'm wondering, you know, do these really need to be polarized? So I'm going to pop this guy out here, and this guy out here. That's the 0.01, that's the 0.5, and try and determine whether or not these are actually polarized. Wish me luck. Aha! You guys are probably all making fun of how stupid I am. We had these 2 resistors in series here, and I was kind of looking for a potentiometer here, but nope, these are the 2 resistors in series. If we do our series resistor calculator, 67 ohms, or 67K, and I measured it, it was 60 something K. I forget what, but that's what's going on there. I don't know if there was supposed to be a trimmer here to get, you know, a tight tolerance or whatever, but we'll find a one resistor that'll do the trick and get the 67 ohms that they were looking for, hopefully, or pretty damn close to it. It'll be closer than it was, so that'll be good. And then, yeah, continue on. We'll whip out these capacitors and figure out what's going on with them. Check this out. This capacitor wasn't even soldered. It was just loose. I mean, it's got mechanical connection around that lug, but it was not soldered. It's all loose. What's going on, Superior Instruments? Letting me down. Alright. This is what I've learned. So I do believe these two capacitors are polarized electrolytic capacitors. I believe the measurement is in microfarads because I measured this guy and it was measuring 2 microfarads. Alright, so if you look at the side, you can't really see it, but it was hard to tell if it was 50 microfarads or 0.50. So I was measuring it 2 microfarads, so that's, yeah, it's drifted, but that's what we're closest to. So I believe that is a 0.5 micro. And both these guys have stripes on one end, and the stripes were lined up with the negative sides, as you would expect here. And this guy here, you can see that he's got a little stripe on him, and that was in this way with the negative end going to the meter. 0.01 microfarad electrolytic capacitors don't really seem to exist, or at least not at a price and a quantity that I can afford. So I'm going to raid the big giant bag of NOS capacitors I have and hope for the best. Alright, so this is what we're going to do. I can get a 0.47 pretty easily from Mouser, so I'm going to order that. And this is basically unobtainium for polarized. But the internet told me that I can use a non-polarized capacitor in place of polarized. So I'm going to trust them, and that's what we're going to do. I'll put a link down in the description, and we will damn the torpedoes. So I'm going to order those parts and any other parts I might need here. And see you in about a week, which will probably be in the next clip for you, right after a SpongeBob screen.
One eternity later.
Alright, we are back with our Superior Instruments Company Model TV-11 tube tester. It's been about a month since the last clip you saw. We had to stop servicing the test equipment here because we needed to order a capacitor to replace this guy here. They asked for a 0.5 at 200 volts. We were able to find a 0.47 at 200 volts, and believe it or not, the best source for this was eBay. And I believe it's a Nichicon, so it's a nice one. And then we also replaced this, but I did a little work today. We put this new electrolytic cap back in, and we replaced these resistors, which, if we can get some light on the scene here, are these two here. So the schematic is calling for a 47K and a 20K pot, it looks like, if I'm reading that correctly, in line. But they had two fixed resistors. They had a 50K and a 7.5K. So what I did was I have two resistors in series, and instead of 57.5K, they're measuring about 57K. So we're not that far off. It's probably better than, you know, whatever dog bones they were using. It's probably closer in value to what they actually need. So that's that. Put a new power cable in, and I added this little clamp here as a strain relief. Got a knot there. We cleaned all the switches and sockets with this stuff here, QD electronic cleaner. And let me flip it over and we'll talk some more. Alright, so we cleaned out all the switches, pots, all the stuff in here with the QD electronic cleaner. And this one especially was really crunchy and just kind of felt rusty. And it is so much better now. As soon as the stuff hit it, it felt better. But sprayed it down on the back and twisted it back and forth a bunch of times, and she's almost like brand new. And everything else is nice and smooth. The line adjust is smooth. Good in the switches, those are all smooth. Yeah, she's almost like new. And then finally, I ordered some more grid caps on the last order I placed for the other amplifier project we're working on, and I proceeded to lose those as well. This is going to be a giant stash of anode caps somewhere in this tone church here, but that actually worked out for the best because I just got some RCA 815 tubes, and they have anode caps, and they're 3/8, so you know, the little 1/4-inch cap wouldn't have worked. So we're going to use a alligator clamp, and that way it'll fit on any size grid or anode cap we may come across. Alright, I think that's everything here. These guys are all cleaned up. The roll chart's working nice. Cleaned out the octal and the 9-pin sockets. I didn't really mess with the other sockets. Don't really need them at this point in time. So I think we're about ready to plug her in and see if she works and maybe test some tubes. So here we go. Alright, I've got the action cam kind of precariously set up on my little storage drawers here. Hopefully you can see everything. So here we go. Step 1 is to test a tube for shorts and leakages. And we're just going to go step by step following the instructions. So step 1 is insert the line cord into an outlet receptacle, check. Step 2, place the power switch up to the on position, check. Step 3, throw the leakage switch up to the tube position. Oop, got some deflection on the needle. Check, we're in tube. 4, throw the 4-position function slide switch down to the line position, check. Step 5, turn the line adjust control until the meter indicates at the line adjust mark appearing in the center of the meter scale. So that's this guy right here. I don't know if you can see it, but there's a line exactly right in the middle, and we need to adjust this to get the deflection of the needle to line up with that. And oh, there we go. And oh, we're maxed out, and we're not quite all the way there. Yeah, this is a little tweaky. Might have to revisit this underneath the hood. But it's damn close. I think we're good. I'm going through the variac. I wonder if I could bump this up a couple of volts. I got it 117 volts off the variac. Let me go up a couple. Oh, there we go. That got us there. So we even have to back her off a little bit. So we're pulling 120 volts out of the wall now. Yeah, this thing's really tweaky.
What about Buck?
It's probably dirty. Might have to change this pot, because I imagine that should be smooth. But there we are. Okay. We are lined up with the line adjust. Step 6, rotate the roll chart until the required tube test data appears. We've done that. We're doing a 6v6. Step 7, turn the filament switch to the voltage indicated on the roll chart for the tube type under test. And filament volts, 6.3, as we know. Check. Step 8, place lever switches in the F and N columns as directed on the roll chart. All other levers should be down in the K position. So under F we have 2, and we have nothing under N. So lever 2 goes to F. Page 2. Step 9, insert the tube into its correct socket. All right, here's our tube. Can we see this? It's a Magnavox 6v6 that I rescued from a console that was in my landlord's junk pile. Here's our octal socket. Plug this sucker in. Alright, we'll give it a few seconds for the heaters to warm up. In the meantime, I'm going to read what Step 10 is telling us to do. Step 10, readjust the line adjust control, if necessary, to compensate for the tube current drain. Alright, give it a little bit. See if we have filament glow, which we do. That's a good sign. And there doesn't seem to be any adjustment needed on the line adjust. So we'll let it ride and we'll go on to step 11. Rotate the load control clockwise as far as it can go, past 10. So it's labeled 0 to 10, and we're going to turn this clockwise past 10. All right. Step 12, move the 4-position function slide switch to the short position. So we need to go up one spot. And the needle deflected all the way to 0. Step 13, one at a time, move each lever, except those previously placed in F or N, up to the P position, which is one slot up. Tap the tube and observe the neon indicator lamp. A glow when any of the levers are moved to the P position indicates a short. So if this guy turns on, we have a short. Each lever switch must be returned to the K position before proceeding with the next element test. Alright, let's see what happens. There's a little flash as it's in between the positions on the switch. I guess that's normal. Hopefully you can see that right here. Alright, we have glow on lever 7. We'll come back to that. Alright. A steady glow on any element listed in the filament continuity column of the roll chart does not indicate a shorted tube. It does indicate filament continuity. And if we look at our chart, 2 and 7 are the filament continuity, so that's normal, and that indicates a good tube. Alright, we just did a test for shorts and leakages. How about that? Alright, let's see if this sucker's any good. Let's move on to the second test. We're going to skip the noise test because I don't know about you, but I don't really feel like plugging in some headphones and sticking that over my brain, you know, right after we just service this thing. We'll wait until we know she's good to go before we start frying our brains out. Alright, to test a tube, place power switch into the on position. Check. Throw the 4-position function slide switch down to the line position. Check. Turn the line adjust. Let's put this guy back down to 0. Turn the line adjust control until the meter indicates that the line adjust mark, blah, blah, blah. We already did that, and line adjust is good. Roll chart check. Filament 6.3 check. Place the lever switches appearing in the F and N columns to the respective positions. And what was that? F2, and that's the only one. F and N. We're not doing anything with P. We have P is 5. All other levers should be down in the K position. Plug in the tube. Redo the line adjust. Rotate the load control to the setting indicated in the roll chart in the load column. Load is 3. Alright, move the 4-position function slider switch up to the regular position, which is all the way to the top. If the letter S appears after the P setting, it does not, so we'll skip that. 12. Read the quality of the tube directly on the meter scale. Alright. Let's see what happens. So we're going all the way up to reg, right? That's no good. Back down. Why do we not have anything in the P position? Place the lever to the P column. There you go. P is 5. Let's try that again. Bam!
You want to take it from here, Emerald? Bam!
We get a working tube tester, and we have a good tube. It's reading about 64.5. Nice. We did it. Cool. Alright, let's test a 9-pin, an AX7 or something. Hang tight for that. Alright, I pulled out a nice... You see that? Probably not. RCA 12 AX7 Alpha. And let's see if we can test this one. So I have not memorized the instructions yet, so we'll go back to the beginning. Plugged in, power on, tube mode, line, wait for the line adjust thingy, bang on center. Oh, we gotta do the tube chart. Bear with me. H, A, J, A, L, big L, A, Q, A, T, A, T, A, T, A, T, A, U, A, U,
Out there in the cold.
A, V, W, 12AX7. And there's two of them, one for each triode. Okay, roll chart, boom. Turn the filament switch to the voltage indicated, and they want 12. That's this guy right here. Lever switches in the F and N columns. F is 4, N is 9, P is 2, but we're not doing that right now, nor are we doing the load. We are checking for shorts and leakages. Stick the tube in. Bam. Line adjust, spot on, turn the load all the way up. Move the function switch to short. Bam. One at a time, check them. Just a little flash. 5, what is 5? Come back to that one. X7, oh, 4 and 5. So that's continuity. So that's all good. Alright, we'll reset it. Turn the load all the way down. Back to line mode. Power on. Tube, line mode, line adjust. Roll chart, filament, and P. Now we need to do the P as well. So that's 2. That's U. Stick the tube in, redo line adjust, load. 3. And check it. I never had any doubts with this sucker. Reading about 64, and it's climbing a little. Oh, this is awesome. Tonepriest is almost legit. So go back down here, and then we'll do the other triode. So 4, 9, P is 7, P is 2, P is 7. All right, and about 66. Okay, I have the lights off here because I want you to see this. You'll see in an upcoming video on the next Let's Build video on an amp I'm working on. I had an issue where I got the thing all put together and I fired it up for the first time and I wasn't getting any signal. And I did some testing and it seemed like there was continuity between one of the plates, or this is a dual triode, it's a 6N7 tube. One of the plates and pin 1, which is connected to the body of the tube, and that was all grounded. I have the pin 1s on the metal tubes that I'm going to be using grounded to act as tube shields. And so we put her on the tube tester, and wouldn't you know, we have a short. Can you see that right here? Son of a gun. Well, shows to go ya. Shows you something. Shows me this is a bad tube. But anyway, I have more 6N7s on the way in the mail. And as soon as they get here, that video will be hopefully wrapped up and should be pretty awesome. Stay tuned for that. Well, there you have it. Not sure there's much more we can do with this project. We have a working tube tester. I got this thing for, I paid like $70, $75 on eBay for this. In unknown conditions, so that probably, you know, had a lot to do with the inexpensive price. But yeah, this thing is beautiful. It's got a nice Art Deco look to it, and it works like it just left the factory floor. I couldn't be happier. All right, folks. Thanks for watching the video. I hope you learned something. I know I did. And we'll see you real soon with, you know, a cool amp. Hopefully next weekend. Something really cool. But until then, rock on.
Done.